Hello everyone, welcome to my talk. My name is James Fielder. I am a senior data engineer at Cox Automotive UK. And tonight, or today, I suppose it's mostly the daytime for you guys in America. I'm going to be talking about the evolution of a data platform. So, what's a bit of an agenda for this? So first, I want to talk about who we are and what kind of things we do. I'm going to talk about the challenges we faced as part of this, our journey towards self-service, what our architecture is and how we've changed this over time, the decisions that we made along the way. And then finally, I'm going to talk a little bit about some of our open source code and where we're heading for with DataOps and how those kind of all fit together. So first things first, who am I? I am the tech lead for the data platform at Cox Automotive UK. I work with Azure, Scala and Spark and kind of technologies in that domain. I initially started moving into data roles in around about 2015 when I started working at the University of Manchester at the Centre for Health Informatics. And I'm very interested in the kind of intersections between data and software problems. I think that that's where I'm most useful as a person. I'm also involved in the technology community here in Manchester, here in for once sunny Manchester, where I co-organise the Lambda Lounge Functional Programming Group and Rust Manchester. So yeah. And then more about who are we. So Cox Automotive is a subsidiary of Cox Enterprises, who are a very large global conglomerate headquartered in Atlanta in the US. And Cox Automotive is a provider of retail and wholesale solutions in the automotive sector. So everything from reconditioning vehicles to auctioning them and things like that. In the UK, we're part of Cox Automotive International, and we focus on the UK and European markets. In terms of the team, I'm in a team called the Data Services team, which is our central data intelligence team. And we do analytics, reporting, data science for our UK and European businesses. So, as I mentioned, to set the scene a little bit, let's talk about some of the challenges that we faced over the last few years. So, as a team, we are a full stack data team. We look after absolutely everything to do with data, from both looking after the cloud environments to writing data pipelines, looking after the storage, doing BI development, and then pushing out data science. And we do that as a team of only 8 people. As part of that, we've had to innovate on kind of our architecture and our solution design, and obviously that's what this talk is going to all be about. But the key thing is that any solutions we build really do have to be supportable by our team from day one. So we support everything in production, and those solutions have to scale well, those processes have to scale well for us as a team. And this is a sort of against the backdrop of a business which is relatively legacy. There's no Kafka with all the data streaming to us with nice Avro schemas or anything like that. There's just SQL databases that we extract from, CSV extracts, and, fairly legacy systems kind of everywhere. So how have we approached this? What kind of things have we done? Well, predominantly, we focus very strongly on self-service and on enabling our teams to do as much as possible with us, to get as far as they can. So what is our approach to this? What does this mean to us? We have, as I mentioned, we have quite a small crew. There's only 8 of us, and we have to be strongly self-service. Our expectation is that our team members, not just the data engineers, of which I am currently the only data engineer, which is an incredibly frightening sentence, but anyway, our team members should all be able to deploy their own data pipelines, own their own data assets from initial phase all the way through to production. And, we pretty much managed to make it to that goal with everything that we do. As part of this, we really, really aim to have as much autonomy as possible for everyone in the data team. Our people are trusted. They have access to the production environments. Well, okay, they have access to development environments and can push jobs into production. They don't have full access to production, but yeah. And, we help them to apply good data engineering practices with the work that they're doing. So what's some benefits of this and what are some challenges with it? Well, one of the biggest benefits for us has been that we've been able to leverage the external experts on the actual data itself by pushing out self-service. So we have a lot of users internally who know the data very well and understand the data, and we really want to give them the tools and the power to actually do useful things with the data. I look at it as, particularly for me in the data engineering camp, I don't really understand the contents of the data. I just want to provide people who do with tools to be able to do good work with it. Thinking in DataOps terms, by pushing this kind of self-service mentality, we can reduce cycle time for projects because we don't have to collaborate. We don't have to have lots and lots of people involved in data projects. Individuals can take things all the way through to production without needing to kind of synchronize and get multiple people involved. However, there are some challenges, obviously, with this kind of approach. And one of them is data engineering becomes a very tough problem in this environment. My job is not only thinking about the kind of data scientists and BI devs and BAs that work with us, not only thinking about their needs, but it's thinking about their customers' needs. So there's two sort of levels to think about. The other difficulty with this kind of way of doing things is that everyone that we hire into our data team needs to be relatively technical, certainly more technical than you maybe would expect for a normal, say, BI dev or data scientist. There is an expectation that they're going to write at least some Scala. There's an expectation that they're going to be able to do Python and things like this. And, that can make finding people a bit more challenging. So how have we accomplished this? And this is kind of what the rest of the talk is going to be about, really. So we in data engineering focus very strongly on providing a stable platform that works well and the tools to enable self-service on that platform. As part of that, we try and keep complexity as low as we can, and I'll talk a little bit more about that as we go. And we try to make it so that publishing a data pipeline is an easy task, that anyone can do it. We also provide tools to really help our users move seamlessly from developing something to actually pushing it over into production. So we have methods of taking, say, some SQL that someone's written in a notebook and pushing that into a production job and having the right data engineering concerns and helping them take the next step and maybe bring that into Scala. We also focus deeply on automation. As far as we are concerned, we cannot possibly be in the position that something requires someone to, click something over and over again or do something over and over again. We need to automate everything so that people are free to actually go and do the work that matters. And we tried very hard to do this. So let's now have a little think about how we manage this from an architectural perspective. And when I say architecture here, I'm really talking about cloud architecture. What is the constituent components of our data pipeline to allow this, our data platform rather. So the data platform at Cox Automotive was initially set up in around about 2016, and the first was built on top of Cloudera and was manually provisioned. So, we would have people set Cloudera clusters and Spark clusters up and Hadoop clusters up in Cloudera and do all of that by hand, SSHing onto nodes and all that kind of thing. And really, this just did not scale out at all. We just didn't have enough people to do it. We couldn't possibly, flex our infrastructure up as we required it and then down again. It was just difficult and presented a lot of problems. So in around about 2017, we moved more to an infrastructure as a code oriented worldview where clusters could be deployed using Ansible scripts, and it was possible for us to more quickly turn these on, do our analysis, and maybe spin them down again. Then in 2019, we really decided to go further with this, and we moved over to Azure Databricks and to using platform as a service instead of requiring, running our own VMs and that kind of a thing. And Databricks has been a wonderful move for us. It's really made the platform an awful lot better and an awful lot easier for us to maintain internally. And so, yeah, definitely a big thumbs up for Databricks. So what does this actually look like? What kind of constituent things do we have in the data platform? Well, at a high level, we have sort of some fairly standard data sources. We take files in from Azure Blob Storage. We get some files from SFTP servers, SQL servers. Generally speaking, as I said, we aren't doing any streaming yet. Maybe in the future we will be, but we're not quite there yet. That's just not where the business is. So we take things in, typically files from these sources or SQL extracts. and then we push them into Azure Databricks, and we really use everything that Databricks has to offer. We use all of the interactive and job clusters and the job scheduler. We use all three of the major languages, or four of the languages if you count SQL, that are supported on Databricks. And then we use all of the kind of managed services around that in Azure. So we've got Azure Data Lake, and we've moved over to Azure Data Lake Gen 2 recently, which is really good. We use container services on the outside, Key Vault. We report using Tableau, which we also just run in Azure. And then of late, we've also added Unravel for monitoring, and I'll talk a little bit about that later on. The other thing is that our outputs, when they're not reporting, typically are also files, so we're not streaming out either, but might change in the future. But yeah, we output to SFTP for some of our customers, output to Azure Blob Storage for some of our internal teams as well for some of the things that they do. But the really interesting thing here is we've tried very hard to keep this simple, and we've tried very, very hard to get as much out of Databricks as we possibly can do in this environment. So yeah, as I mentioned, we try very, very hard to make Databricks do as much for us as possible, and we use almost everything that you can imagine Databricks does. This infrastructure and this setup has been significantly cheaper for us as a team. I think just by switching to Databricks, we more than halved our cloud costs, which really tells you just how much sort of better it is to take those platform steps, up to the next level. One quite interesting thing in this architecture, and one of the things that I speak about when I talk to people about it, is that we don't have an orchestrator. So there's no Airflow, there's no Oozy, there's nothing like that. And this really has been a conscious choice on our part because of that self-service goal. If we added an orchestrator, we then need to teach people how to use it. We need to teach people how to add jobs to it, monitor them. It'd be more than one place to do it. And so we've consciously decided not to have one. In the future, we might do. And as I mentioned as well, all managed storage, which once again makes our lives very easy. So what about the future for this? Where are we going with it? Well, at the moment, I would say we're in the position that we've kind of deployed these resources mostly just by kind of going on the console and in Azure and deploying them out by clicking things. But the next move for us really is to a fully infrastructure as code environment, and we're currently experimenting with deploying it all out using Polimi, which if you've not looked at it, do have a look at Polimi, it's amazing. And we want to use Azure DevOps to do that. We also want to use Azure DevOps to deploy all of the pipelines as well, which we currently have a custom written tool, which is okay, but we probably need to can standardize it a little bit and go for something a little bit more software engineering oriented. The other thing that we're considering is using Azure Data Factory a bit. We're very keen on managed services, and Azure Data Factory might help us to ingest things that we maybe don't have the patterns for right now, especially if they're a little bit more ad hoc and we don't want to build something for it. We may want to bring an orchestrator in the future, although we're trying hard not to, because once again, it's really good. You've got to justify bringing it in for the architectural complexity. Unravel is another thing. I mean, Unravel's not really the future. We already have it. And big shout out to Unravel. They didn't ask me to praise them or anything in my talk, but it is a really, really useful tool, especially if you're interested in kind of optimization and observability in your Spark jobs. We're a big fan of it, and we're going to be trying to get as much out of it as we can. So yeah. The other future for us is there are some requirements coming along which are a bit closer to software engineering type requirements, so building APIs over the top of our data. And for those, we're kind of having a look at serverless and using Azure functions. So how do we make these choices? I've kind of hinted a little bit at these, but really the number one thing for us is we want to keep it simple. We don't introduce something unless we need it. That's why there's no Airflow, there's no Oozy like this. We've just not had the need, so we don't introduce it. We also favor platform as a service as much as we can. We really want to push out to the platform as best as we can do and get them to do the hard work. I don't, as a solo data engineer currently, I don't have time to be a sysadmin as well and be SSHing into things and doing that kind of stuff. So we try hard to push out platform as a service. The other kind of philosophical thing that we have is that we're we're keen, or rather okay with the idea of building our own tools to orchestrate, building our tools to formalize and automate those best practices for us in our environment, and building libraries to kind of extract out common functionality and do things once well as opposed to many times badly. And then as a kind of final thing, we try hard to make one Spark job do as much as possible. You know, we don't want to get into the position of having multiple Spark jobs in a chain if we can avoid it, because it breaks observability, it makes it harder to test, all these kind of things. So let's delve one level lower and have a think about how we've done this from the software level. So I thought I'd start this section with a quote, and the reason is that I think, much like Alan Kay says here, there is nothing in software engineering that is like the construction of the Empire State Building in less than a year by less than 3,000 people. They use powerful ideas and power tools that we don't yet have in software development. I think one of the things that we've got a lot of value out is trying to build some of these power tools, and in particular, building our framework, YMAC, which is open source and available on GitHub. I'll provide a link at the end of the talk. But YMAC is effectively a data engineering framework that is our attempt at wrapping up all of these best practices and ideas and ways of doing things in a library that we can then reuse, and our colleagues who are not data engineers, so our business intelligence developers, our data scientists, can use to do these data pipelines without really needing to know the absolute intricacies of Spark, which is, what we've basically got to. So, as I mentioned, it's our data engineering framework. It's written in Scala. And the key thing that YMAC really gives our users is the ability to embed data flows. And by that, I mean kind of DAGs, effectively, of data flows into a Spark job, and have the framework manage the parallelism, have the framework deal with all of the environmental concerns, getting secrets, being able to deal with partitioning tables correctly. All this kind of stuff is lifted into this framework layer. YMAC is very, very, very central to how we've designed everything that we do. All of our production data pipelines are written on top of it. We use it basically for everything at this stage. And so hopefully it's good. So philosophically, YMAC tries to model the idea of what a data pipeline is. So here's this is a diagram taken from the documentation, which sort of tries to articulate the idea that often data pipelines really have lots of stages that obviously could run in parallel and that have a similar structure. So in this diagram here, we're trying to load from some tables, and then we do some data type cleanup and we do some joins. So if you think about it, if you could model these actions as at the code level, then you could actually use the framework to deal with parallelism and all these kind of things. And that's exactly what we do with YMAC. So just as a sort of teaser, this is the kind of Spark UI for a job that I wrote, which loads a bunch of tables from one of our sub companies, and we have to ingest the data and then report on it. And this loads up about 8 tables. It's quite a small job. It's one of our smallest jobs, actually. This loads 8 tables and then does some joins, changes some data types, all that kind of stuff. And when I was doing this, I didn't deal with anything about parallelism. I didn't think about how I was going to wrap these up into tasks in Spark and sort all that out. I merely wrote YMAC code, and YMAC deals with all this parallelism. YMAC figures out what can run concurrently, and builds out this well parallelized execution graph for us, and that's definitely that's the absolute strongest part of the framework. So I don't want to go too much into the code on this, just because there's only so much time left. But this is kind of what YMAC looks like. The idea with YMAC is that we create a flow, and that flow is effectively a program which represents a data pipeline. And then you place actions on that flow, and that creates a sort of data structure which represents the actions that Spark needs to take. And then once you're done with that, you ask the executor to execute it, and it works out what can be done in parallel and does it for you. So on this particular flow that we're looking at, Table 1 and Table 2 are some named outputs. Those are what we call labels, and they will be loaded in parallel because they have no dependencies on any other labels. But the transformation below it, which requests table 1 and table 2, and therefore has a dependency on both of those actions finishing. So we will wait until those tables are loaded and then call the transformation action. And then once that's complete, we create a new label called out, which contains the result of the code that you can see inside of the transform step. And then finally, we write to a Hive managed table called CSV, and we write the label that we write whatever the data frame is that's at the label called out. And as you can see here, there's no mention of parallelism. There's no mention of how one would execute this. We just merely state what we want to happen. It's a kind of declarative runtime. So since we're at a DataOps conference, it's probably reasonable for me to talk at least a little bit about some DataOps. And YMAC really helps us with a number of things in the kind of DataOps space. In particular, I'd say it makes testing much easier, as we have a unified way of creating outputs and indeed actually getting inputs. And then we can kind of write unit and integration tests for pipelines on top of the framework. We've also integrated Amazon DQ so that we can do some assertions on data frames and use those kind of assertions that are quite useful like that. YMAC also helps us reduce cycle time by basically allowing us to move from ideas to production quite a lot quicker, since so many of these concerns are taken by the framework instead of having to be, rewritten in another pipeline. And then finally, YMAC does some of the things an orchestrator does. I don't want to say that it completely replaces an orchestrator, because that wouldn't be true. But YMAC certainly takes on some of those concerns that an orchestrator would normally have to deal with by allowing us to embed these graphs. Okay, so that's kind of where we are today. Where are we going next? What kind of things are we going towards? Well, I would suggest, as a team, we've done quite well at getting ourselves to a good place in data terms. So what I mean by that is we have a working data platform, we have working data pipelines, we're ingesting data, we're reporting on it well, but we need to improve our software engineering side. And once again, this is another one of those sides of DataOps that I think a lot of teams struggle with. So we're trying to improve our deployments, get to CI/CD, and improve our testing approaches for data in general. And once again, YMAC's helping us there with giving us the tools to do that. We're really trying to move towards a fully IAC deployment for everything, and we're hoping over the next year or so get to the point where we can effectively just spin our environment up almost automatically using infrastructure as code. Throughout all of this as well, the themes of self-service continue. We really want to continue giving our business power users more of options to look at the data, ways to and analyze their data, ways to interact with their data. And then for YMAC itself, we really do need to improve the documentation a bit. I am very much aware of that. And we need to open source some more tools to make it easy to work with the framework. So a test kit, maybe a flow visualizer, probably some kind of additional tooling around deployment as well. So yeah, that's basically the end of my talk. But as sort of 4 takeaways and 4 conclusions, for us, I would say, we've tried very, very hard to fight architectural complexity and software complexity, but certainly architectural complexity in the data platform to be as agile as we can. The more things that you bring in, the harder it is to be agile. The other thing is that we've been unafraid to build our own tools, and I think this is something in general I would recommend to people. If there's a process that you can make a tool do, then do it, build it. It's probably going to pay off in the long term. And if you're going to adopt a tool, if you're going to go out and get a third-party tool, you're going to buy it, or you're going to go and pick up YMAC off GitHub, make sure that you're really getting the best from it. Once you adopt a tool, really, really use it as best as you can. And finally, and I suppose this is, one of those things that is often said about software in general, don't just follow the hype, because all of the fundamentals are the same. We're still doing SQL. We'll all still be doing SQL in 20 years' time, because it's just great. But yeah, that's it. Thank you very much for listening. I'll have a look if there's any questions now in the Q&A. But yeah, the other thing I would say is if you want to know more about WiMAC in particular, my predecessors in this role did a Spark Summit session on it in 2019. And if you Google for Spark Summit WiMAC, then you can watch that, and that goes a bit more in depth about some of the kind of rationale and how we've done things with WiMAC. Anyway, I shall have a look at the Q&A now. Look. Oh, sorry. I've just there was a question from Kevin. Looking back, do you feel that your implementation schedule was realistic? Could you change anything in hindsight? Implementation schedule for what? I think if you mean for the data platform, then yeah, it's been realistic. I think we've made the changes that we needed to at the time. Yeah. Let's have a look at some of the other questions. Okay. Are you hiring at Cox on your data team? Yes, we are hiring a senior data engineer at the moment. If you go to careers.coxauto.co.uk, then you'll see that job on there. I will post a link to that before I finish the session, though, so I'll leave that. Another question. If your data science algorithms, can you please talk? Okay, so interactions between our data science algorithms and data pipelines. So this is something that we are consciously aware of, because one of the issues that we have pushing things out into Scala is that Scala's data science library ecosystem is not as kind of vibrant as Python or R, but then the inverse is true when it comes to data engineering. The answer there is that we have some data science stuff written in Scala, but often the way that we'll do it is that we'll kind of run a data pipeline up to a point and then output some stuff and then maybe run a notebook to do the final data science stuff. But it is something that we are consciously thinking about, because there's more and more use cases where we arrive at the point where we think, well, actually, we want to do everything all together. So I know that's not a very good answer, but we're still thinking about it. We're still thinking about the right way to do it. Okay. As you made the data platform self-service for users, what guardrails have you put in place? I would say the guardrails are WiMAC in of themselves, in that we say, if you want to put this into production, we expect you to use that, and that sort of takes a lot of the burden of those production things. The other thing is that there is we only allow so much access to the production for non-data engineering users. So there's only so much that they can do. But so far we found we don't need too many guardrails. We just try and trust people as best as we can do, really. A question from Ben. Where has Unravel had the biggest impact on the team and business? And what part of Unravel could you not live with if it was taken away? Thanks, Ben. I would say for us, Unravel's been particularly useful. We're trying to do a lot of things around optimization for our platforms at the moment. So optimizing our virtual machine choice on Databricks, optimizing our jobs, try and make them run quicker and cost less. And Unravel just gives us a lot of visibility into what the jobs are doing and, how much memory they use over time and all this kind of stuff that we really struggle to get ourselves and to build ourselves. So I'd say, yeah, Unravel has been particularly useful for that. And if we lost that visibility and that observability that Unravel gives us, I think we'd be quite upset. So yeah. So yeah, and then I answered that. I think I've answered all of the questions in Q&A now. So if there is any other questions, please do let me know. There's a question in the chat. Does WiMAC support GCP? So the answer is there are certain things in WiMAC which are Databricks specific, but the vast majority of it is just plain Spark. So in GCP, I think it's called Dataproc, I think is their own Spark clusters. And yeah, it should run fine on the GCP version, like the GCP managed Spark. You might have to write an extension that could say use like GCP specific secrets management or GCP specific storage. But in terms of just pure Spark, it will run fine anywhere that it's just a standard Spark platform. Okay, so I think that's about it. I don't think there's any more questions in the Q&A. So yeah, I'll just wait a second if there's any more, and then I think I'm done, and I think I've had my time, so probably time for me to come off anyway. Yeah. I'll tell you what, I'll post a link to our current senior data engineer job, because that will make my boss happy. Yeah, someone's just pointed out in the Q&A that Databricks is on GCP. That is true as well. I think Databricks and GCP is built on top of Kubernetes, so it might use the Kubernetes internal secrets management. That would also be, it would be very much possible to support that as well. We just haven't done it because we don't have, we're not in GCP. That's all. Right. So I'm just going to post our job, and then I'm done. Yeah. All right. Thank you very much, everybody. Yeah, I hope this was useful. If you're interested in YMAC, either check out the talk, check it out on GitHub. We're still actively developing it. I'm hoping to add Databricks Delta support quite soon, over the next sort of 3 months or something like that. So yeah, thank you very much, everybody, and enjoy the rest of the conference.